This is the second video as part of the Control101 Toolbox series, which focuses on Simulink, and we're going to continue with basic usage. So just a reminder then, so the communities agreed on an outline structure for a Control101 course, and it was decided that such a course would benefit from a MATLAB toolbox to support it, because MATLAB's visualization and number crunching tools naturally fit with control and systems, and they're easy to use. This video, however, is going to focus on the Simulink tool. Now, the focus is very much on introductory simulation and control, and we're not going to look at the far wider uses and potential of Simulink and its toolboxes, which go far beyond the needs for a Control101 course. Motivation for Simulink then, and some reminders. So with Simulink, rather than using code, users can build models using blocks, and this is often more intuitive and easier to do. It also allows the inclusion of varied and important components, nonlinearity, and so forth. But an important warning, unlike with M files, Simulink files are not always backwardly compatible, so you might need an up-to-date version of MATLAB to use some of the files that are in the toolbox. So then, let's get on with this video. The previous video introduced users to blocks, their connection, and the settings, but not how to run the files. And it's important we learn how to run the Simulink files, not just from the Simulink window, which I'm skipping, but also from a MATLAB script. And how do we enter the required parameter values into the Simulink blocks? In the long term, it's a lot easier to do this from a script because it's more efficient, because you can use loops to do things like change a parameter systematically and overlay the plots that you get from the simulations with these different parameters and so forth. So I'm very much a believer that run your Simulink files from a MATLAB script. It makes your life easier and more efficient in the long term. So this video is going to look at this particular live script file, Intro to Simulink for System Behavior. And it's the starter file, basically giving you a gentle introduction to running Simulink files from an M file. So the live script provides several example Simulink files and the associated code to run the file and produce plots. And all you need to do actually as a user is work through those files and hopefully pick up knowledge and understanding as you do so. So what's in this live script? You can see the master file name, and then the other files come in pairs. You can see there's 4 different examples which are listed here. So there's a Simulink file and the associated MATLAB code to enter the parameters and run that file. And we will demonstrate that now because it's, as always, much easier to see these things with a live demonstration than otherwise. So here is the main live script file. So you just need to open this live script file and that will do everything else for you. So you can see you've got the header. I'm not going to read that for you. You can do that in your own time. And you can see here's example 1, a simple car speed model. And here's the Simulink diagram. Okay, and it tells you where that's stored. It's in this particular file, so you can find it if you want it. And then if you go down, it gives you some instructions on how you might run it, and you'll see it tells you the associated script file is this one. Okay, so if you want the script file, which is running that Simulink file, that is in there. But let's look at the Simulink file first. I'll bring it across so you can see it. Here it is, a very, very simple Simulink file. Now, you'll notice at the moment there's red shading around these blocks, and what that's telling you is they're looking for values in the command space which don't currently exist. So I haven't defined num, I haven't defined den, I haven't defined throttle profile. So it's giving me warnings, and that's basically saying you've not defined them yet. But don't worry about that because that will come later. Now, let's look at the associated M file. So here it is, I've got it open for you. And you can see, what does this script file do? The first thing it does is it defines some values. There you are, C, M, and B. Now, let's have a look and see where they come in to this. If I open car model, what can you see? The car model needs the parameter C, the parameter M, the parameter B. Okay, what's in this throttle profile? It needs basically this variable throttle profile. So now if we look at the code, can you see what the code's doing? It's defining all those values and basically putting them into the workspace. And the nice thing is you can very easily change these values and then just rerun the script file. And then to run the file, I'm just using this command here. Okay, and then at the end, I can do this plotting. Now, if we go back to the live script, you'll see this is done for you here. Basically, you just run it here, and what you see, here are the results. Okay, so it's done for you, and the results come out. Now, if you want to make changes, you just go to your script file, change the values, and rerun. So there's another example down here. I'm going to skip this one, but you can open it. You can see this. There's the Simulink file. There's its name. And here's the name for the script file if you want it. But let's go down to the third one, just to do something different. So that's this example here. So again, I can bring in and show you the Simulink file. And again, you'll see all that red because I've not defined things in the main workspace. And you can see it's a slightly more subtle diagram, but we don't need to worry too much about that level of detail. So let's move that out of the way again. And if you want to see the associated M code, here it is. Define all the values, run the simulation, do the plotting. And you'll see that within the live script, it's done it for you. You can see there you are, and here's all the plots. This is investigating what happens when you change gear. If it's not obvious, you can see from these plots how you get changes in acceleration and the like when you change gear. So there are other options as you go down. So the fourth one, again, introducing limits. So we have talked about how Simulink is really valuable for introducing non-linear components. And you'll see there's a block here, which is a non-linear component, and you'll see the impact on the plots. So the key point in this file is that you go into those M files. Let's go into this one here, and you read them. And you say, okay, what's going on? I can see here it's defining the values. I can see it's doing the simulation. I can see it's looking at the output data, and it's arranging a plot. And in theory, if I just press run here, it will run. And although you can't see it, it's produced the figure outside of the live script because I've now run it outside of the live script. So I could, if I wanted, say, all right, let's change that C from 2 to 3 and press run. And then you'll see the figure changes. You get a different set of results. So you see the point, very, very convenient way of running Simulink files. Define all your parameters so you can, they're very clear, you can change them and you just press run and you get your updated plots and so forth. So some conclusions. We demonstrated how to run and use this particular live script in the Control101 toolbox, which introduces students to how to write script files to automatically populate the parameter values in a Simulink file and then do the simulation. And several different examples are given. The next video is going to look at some other toolbox resources which focus on case studies.